Today I'm doing a demonstration egg in the bottle. So we're going to be considering air pressure and how changing conditions can affect pressure. So I have a hard-boiled egg, and right now we have the molecules in the atmosphere all moving around, bouncing on the sides of the container, pressing in on the container, and the air that's in the jar is pressing out. So we have pressure in and pressure out. When I put the egg on the top, now there's trapped molecules of air that are pushing up on the egg, and then we have the atmosphere pushing in on the egg. So I'm going to now change the conditions by heating up, putting this paper on fire, and putting it in our jar to heat up the molecules, and we'll see what happens. Oops. Okay. All right, so as we can see, the egg ended up in the bottle, and we're going to go over step by step what happened. How did that egg get in the bottle? So think about this. Do you think that the egg was sucked into the bottle, or was the egg pushed into the bottle? And if so, by what? We're going to break our egg in the bottle down into 4 phases. And we're going to be considering pressure, temperature, moles, and volume. So our phase 1, that is the initial setup. So we have our egg that is on top of the bottle, and in the bottle we have air. And those air molecules are moving around, and they are pushing up on the egg. They're pushing against the sides of the jar. The molecules push evenly on all sides of our jar. Outside of our jar, we've got air molecules as well. And those air molecules outside are pushing on all sides. They're pushing on the egg, pushing on the jar. So we have the air molecules inside pushing up on the egg, and we have the pressure of the atmosphere pushing down on the egg. We also have the weight of the egg that's pushing down, but it's being held up by the edge of the bottle. So initially, we can say that the pressure inside the bottle is equal to the pressure outside of the bottle. And we have our number of moles are trapped. So we'll just call it N. So N moles of air are now trapped in the bottle. And the volume of the gas in the bottle is the volume of the container there. Okay, and our temperature is room temperature. So we can say that the temperature inside the bottle is equal to the temperature outside of the bottle. All right, phase 2. Now we have a burning paper in the bottle. So what is that burning paper doing? The burning paper is heating up the air molecules in the bottle. So the molecules in the bottle heat up. That means they move faster. And the pressure increases in the bottle. We also have a combustion reaction happening. Our solid paper is producing some carbon dioxide gas, some water vapor gas. So we also have combustion producing moles of gas. So at this stage, the pressure inside is greater than the pressure outside, and the number of moles inside is greater than it was before. So at this stage, the pressure inside becomes greater than the pressure outside of the bottle. All right, so that brings us to phase 3. In phase 3, if you go back and watch the video and look at it very closely, you'll see that egg jumping up and down. So the flame goes out and the egg jumps. Whoops, the egg jumps up and down. So the egg jumps up because the pressure inside is higher than the pressure outside of the bottle because of our fast-moving particles and because we have more particles of gas. So we have particles escaping when that egg jumps up. So then it seats down and then hops up. So gas escapes the bottle. So the number of moles of gas inside the bottle goes down. So we still have our hot gas, the particles inside, though we're moving faster than outside. So the gas particles inside are moving faster than the air molecules outside. So there's less of them because we have gas escaping. We'll put our gas in here. Less of them, but they're at a higher temperature. So now in our last phase, okay, the egg is seated in the bottle. This gas is trapped, and the temperature goes down. And as the temperature goes down, our molecules move slower and slower and slower. So as the temperature goes down, the gas particles inside move slower and slower. And that means that the pressure inside goes down. And it goes down, and as it goes down, the pressure inside becomes less than the pressure outside. So we have a greater pressure outside than we do inside. So it is the pressure of the atmosphere that pushes the egg into, there's our egg, pushes our egg into the bottle. So it is the pressure of the atmosphere that pushes the egg into the bottle. So the egg does not get sucked into the bottle. The egg gets pushed into the bottle when the pressure outside becomes greater than the pressure inside.